One of the most interesting things that has come out of Cluster has been the ability to take the data that's out in the magnetosphere and then compare it with the ground data. Across the ground it's much easier to put out instruments. Still can be in very cold and inhospitable regions, but it's not as much money as launching something into orbit and hoping that it works. So what we're able to do with Cluster is trace the magnetic field lines back down to the Earth, and then use the great suite of instruments that we have down on the Earth from various different countries, various different universities, and put all this data together to give us a better idea of what's going on in the near-Earth environment in which we live. The ground side of it, the ionosphere, the atmosphere, what we pick up in ground-based instrumentation, is very much the last effect that we see. So that's probably the bit that's of most interest to people in their everyday lives, whereas the stuff out at Cluster is what causes that. So we're trying to link these two processes together. When we look at the aurora and the dynamics within the magnetosphere, what we're actually looking at is the deviations from a perfect system. If everything were perfect, then the magnetosphere would sit there, it would be completely inactive, nothing would get down and affect the Earth, there would be no aurora, it would just sit there, and that would be it. Unfortunately, it doesn't do that. Through interactions with various other bits and pieces, in particular interaction with particles and magnetic field that stream off the Sun, this system is imperfect, so the protection that it gives us from those particles is imperfect. And it's those particles that are streamed down into the auroral regions. And when we look at future spaceflight missions out to Mars and so on, we have to consider how do we protect astronauts in those long missions. And one of the ideas has been to create mini magnetospheres, so to somehow generate a magnetic field on the spacecraft that can surround the spacecraft and protect it just like the magnetosphere at Earth does. But if it protects like the magnetosphere at Earth, it must also fail like the magnetosphere at Earth. So it's very important to understand the consequences of how this magnetospheric system fails, how it breaks down, how we get these big auroral events where we see these particles streaming down into the aurora, and trying to work out how these might affect astronauts if we put them in this magnetized environment on their way to Mars, Saturn, Jupiter, or wherever.